This is all the plastic shit that I found in my house.
Around 26 million tons of plastic ends up in the ocean every year, where it becomes part of something much bigger. In the Pacific Ocean, plastic from America is swept into a large revolving ocean current known as a gyre. As this current circulates, it also picks up material from East Asia. Over time, these plastics accumulate in enormous flotillas. One of them is so big, it's even got its own name: the Eastern Pacific Garbage Patch.
The United Nations estimates that there's about 85 billion pounds a year of electronics waste that gets discarded around the world each and every year. And that's one of the most rapidly growing parts of our waste stream. And if you throw in other durable goods like automobiles and so forth, that number well more than doubles. And of course, the more developed the country, the bigger these mountains. Now, when you see these mountains, most people think of garbage. We see above ground mines. And the reason we see mines is because there's a lot of valuable raw materials that went into making all of this stuff in the first place. The metals we typically get from ore that we mine in ever-widening mines and ever-deep mines around the world. And the plastics we get from oil, which we go to more remote locations and drill ever-deeper wells to extract. To put that in perspective, and I'm using steel as a proxy here for metals because it's the most common metal, if your stuff makes it to a recycler, probably over 90% of the metals are going to be recovered and reused for another purpose. And there's more plastics produced and consumed around the world on a volume basis every year than steel. They have very different densities, they have different electrical and magnetic properties, and they even have different colors. So it's very easy for either humans or machines to separate these metals from one another and from other materials. Plastics have overlapping densities over a very narrow range. They have either identical or very similar electrical and magnetic properties, and any plastic can be any color, as you probably well know. People for as little as $1 a day pick through our stuff, they extract what they can, which is mostly the metals, circuit boards and so forth, and they leave behind mostly what they can't recover, which is, again, mostly the plastics. Or they burn the plastics to get to the metals in burn houses like you see here, and they extract the metals by hand. Well, this is a photo I took standing on the rooftops of one of the largest slums in the world in Mumbai, India. They store their plastics on the roofs, they bring them below those roofs into small workshops like these, and people try very hard to separate the plastics by color, by shape, by feel, by any technique they can. And sometimes they'll resort to what's known as the burn and sniff technique, where they'll burn the plastic and smell the fumes to try to determine the type of plastic. So what are we to do about this space-age material, at least what we used to call a space-age material, this plastics?
This is the Padworth facility. You can see we're storing mixed bottles and recyclers here. This is the recycling process. And up there we're using the Magpie technology.
Normally at a standard MRF, you just separate out the mixed plastics and they go to another facility to be sorted. What we're able to do here is to separate all the plastics out into the different streams. They're of much higher value if we do that, and you can recycle more materials.
So here we're in the heart of the facility where you can see the material that's collected and stored. We pre-sort anything that shouldn't be there, and then we go through the magnet system, taking out metals, and then finally onto the Magpie system where we're separating out all the different plastics into the individual components.
How it's set up is it shines a light onto the conveyor belt, and depending on what the plastic is, a different amount of light will be reflected back to the machine, and then it's calculating what is the most valuable and most frequently found plastic. So if it's looking at the belt and it sees lots of plastic bottles, it will shoot those plastic bottles off with air jets. And the rest of the material will go back round, and then something else will be more frequent and it will choose that material. With this Magpie technology, we don't have to come in direct contact with the waste so much, but we still do need people in order to make sure the machine's working and to do the quality control.
Finally, you can see the bunkers where we have the different materials stored, and they're baled and they go off to market.
The Magpie technology was developed by our R&D team in France, and there are 2 pilot facilities in France, and this is the first full application in Europe. It's a unique application of the infrared sorting, and it enables us to use one machine where normally you would need to use at least 4 or 5 machines. So it means we're more energy efficient, our carbon footprint's lower, and we're getting changes into the future, and different types of materials are manufactured. We can reprogram the machines.
The traditional way to make plastics is with oil or petrochemicals. You break down the molecules, you recombine them in very specific ways to make all the wonderful plastics that we enjoy each and every day. It certainly doesn't cost as much as oil, and it's plentiful, as I hope that you've been able to see from the photographs. And because we're not breaking down the plastic into molecules and recombining them, we're using a mining approach to extract the materials. We have significantly lower capital costs in our plant and equipment. We have enormous energy savings. I don't know how many other projects on the planet right now can save 80 to 90% of the energy compared to making something the traditional way. And we make a drop-in replacement for that plastic that's made from petrochemicals. Customers get to enjoy huge CO2 savings, they get to close the loop with their products, and they get to make more sustainable products. It starts with metal recyclers who shred our stuff into very small bits. They recover the metals and leave behind what's called shredder residue. It's their waste. A very complex mixture of materials, but predominantly plastics. We take out the things that aren't plastics, such as the metals they miss, carpeting, foam, rubber, wood, glass, paper, you name it, even an occasional dead animal, unfortunately. And it goes in the first part of our process here, which is more like traditional recycling. We're sieving the material, we're using magnets, we're using air classification. It looks like a Willy Wonka factory at this point. At the end of this process, we have a mixed plastic composite, many different types of plastics and many different grades of plastics. This goes into the more sophisticated part of our process, and the really hard work, multi-step separation process begins. We grind the plastic down to about the size of your small fingernail. We use a very highly automated process to sort those plastics, not only by type, but by grade. And out the end of that part of the process come little flakes of plastic, one type, one grade. We then use optical sorting to color sort this material. We blend it in 50,000-pound blending silos. We push that material to extruders, where we melt it, push it through small die holes, make spaghetti-like plastic strands, and we chop those strands into what are called pellets. And this becomes the currency of the plastics industry. Instead of your stuff ending up on a hillside in a developing country, or literally going up in smoke, you can find your old stuff back on top of your desk in new products, in your office, or back at work in your home. And these are just a few examples.
The average European junks about 525 kilograms of waste each year. I mean, that's a whole lot of stuff. And much of it really is stuff as opposed to waste. Useful stuff, worth money. All in all, it's just a waste of waste, isn't it? So, what can you do about it? Okay, so you've got your half a ton of waste, which might not make you half a ton of money, but it could make you some. And off we go. A lot of the stuff in the bag is pretty useful as it is. Some bottles just need a wash up and a new cap. And old clothes and furniture come back into fashion before you know it. Some of it might need a bit of repair, but hey, that's job creation right there. Can't be a bad thing, can it? That's it, we're talking reuse. You might need to spend some money to make this happen, but since useful stuff is valuable, you'll get it back. And then some. Now, some of your waste might be useless in itself, but made out of good stuff, like metal, glass, paper and cardboard, all of which can be utilised again if you treat it right. And in fact, some of the really weird stuff used in electronic gadgets is so scarce that we actually need to use it again, if we don't want to run out. And yes, it's called recycling. Of course, collecting and processing isn't free, but here's the clever bit. Recycling turns your waste into useful stuff that can be sold. And as if by magic, new jobs will appear as well. So let's have a look at what's left in the bag. Food leftovers, used cooking oil, some wooden paper, lots of plastic and smelly stuff like cat litter and used diapers that sadly can't be reused or recycled. Or can it? Actually, it can. If you burn it to generate power and heat buildings, and collect the biogas to use as fuel, it might not smell of roses, but hey, this is useful stuff. Of course, you need to make some initial investments, but in the long run, burning waste is definitely a whole lot cheaper than burning oil or coal. Same with greenhouse gas emissions. No contest really. And then there's job creation again. This neat little trick is known as energy recovery. Not much left in the bag, is there? A whole lot less than half a ton, that's for sure. Time to get rid of what's left at that place we all know and hate. Sadly, it can't be avoided completely. Some waste is simply useless and won't even burn. Ah well. Of course, you don't want poisons lying about, so harmful stuff needs to be securely destroyed or stored out of harm's way. Safety first, of course. And there's job opportunities there as well. But hang on a second, do you really need to create that much waste to begin with? Come on, it's half a ton for crying out loud. Of course you don't. We could all begin by actually eating the food we produce. Today half of it goes into the bin somewhere along the line. I mean, that's just wrong. Another good idea is to steer clear of disposable containers and packaging. And why not try reading the paper online instead of on paper? And so on. The trick is to reduce the amount of stuff you throw away in the first place. So there you have it. And you know, the cool thing is that all this is being done all over Europe as we, or rather I, speak. For instance, in Norrköping, Sweden, 4 local fuel and power companies literally live off each other's waste. The stuff that one company discards becomes the next one's raw material. And round it goes. Brilliant. Meanwhile, in Hungary, a mushroom growing company have this really sweet sideline going. An electric power plant fueled by biogas made from mushroom scraps and used growing substrate that produces marketable green power. And in Cumbria in the UK, the county waste management people have worked with teachers and pupils to turn the Cockermouth School into a sustainable school. This is good news in more ways than one. Not only does the school chuck away a whole lot less than before, but the pupils have become expert reusers, recyclers and reducers in the process. And that's vital. After all, we're not born with sustainability skills. We all need to learn them. It's not like it's rocket science or anything, but still, knowledge is power. Green power. So, education and information is a big piece of the puzzle, no doubt. Costly, sure, but then again, you need to create jobs, don't you? I mean, let's face it, wasting your waste is such a waste.
In many ways, it feels like modern life is detached from the planet, but actually, we're linked to it in hundreds of subtle and surprising ways. This plane is a huge conglomeration of natural resources that have all been precisely extracted, transformed, moulded and connected by us. And what's staggering is the scale on which we do this. This airbase in the Arizona desert is home to over 4,000 planes. Many of them will never fly again. Effectively, this is a vast accumulation of the planet's minerals.
So if everything is connected, can we transform the world through ecologically intelligent design? To architect William McDonough, we must not only embrace new philosophies, but also innovative business strategies to reshape the world economy. His co-authored book, Cradle to Cradle, looks at how goods and services can generate not only economic value, but also ecological and social value.
The problem with recycling as we conventionally practice it or characterize it is that in most cases it's really what we've characterized as downcycling. The materials are losing their quality as they go through the system. We're calling for what we call upcycling. So it's either true recycling or even getting the product better. A bottle, for example, take a look at this bottle. This is polyester terephthalate. It contains antimony, which is a toxic heavy metal, as a result of catalytic reaction, the catalyst that is used. This is idiotic because I don't need antimony in this bottle, and it's a beautiful material and can be infinitely reused. But right now, this will go off and become a park bench. It won't be reused as this. Plus, it's got this slightly toxic material. It doesn't affect you drinking the water, but it does affect the whole system. The system is contaminated by a carcinogen, which is just bad design. It's totally unnecessary. In order to be a living thing, you have to have growth, you have to have free energy from sunlight, and you have to have an open system of chemicals operating for the benefit of the organism and its reproduction. So what Dr. Michael Braungart and I are looking at with Cradle to Cradle is the idea that human artifice could follow the laws of life itself. And we would need growth, free energy from sunlight, and an open system with chemicals that are safe and healthy. So the real question becomes, when do we find ourselves in kinship with the natural world? When do we find ourselves as part of the natural world? And that's why Cradle to Cradle is so important. In nature, nature's not efficient. It's effective. So a cherry tree in the spring is not very efficient. Thousands of blossoms so you can get one tree to reproduce. It's not that interesting as far as efficiency goes, but it's magnificently effective. So we're looking at both human technology in terms of our comfort and our ability to thrive as a species, but also how would we integrate that into the natural world without destroying it? That's a fundamental question that we haven't asked as a species. We become part of the human resource of the natural world instead of simply seeing nature as natural resources of the human world. Well, Cradle to Cradle is a simple, commonsensical approach which says things either go back to soil safely and forever or back to industry safely and forever. So we design products that were going to end up in the dirt, like a paper plate. Why not design that with a little nitrogen in it so when you throw it away, the farmers want it? If we look at the products like cars or computers, those are things that want to go back to being cars and computers. So right now they become toxic waste. Why couldn't they go back into closed cycles? We see this happening as a small part of something really huge that's pretty much out of control.
Design today must reflect a new spirit. By employing the intelligence of natural systems, we can create industry, buildings, even regional plans that see nature and commerce not as mutually exclusive, but mutually coexisting.
The first industrial revolution was an aggregation of a lot of individual acts based on specific opportunity. It wasn't designed as a whole system. And now that we've seen the result of the whole system of the first industrial revolution based on brute force and the use of fossil fuels, we should stop, take a breath, or try to anyway, and say, wait a minute, You know, was this designed? Was it our intention to release mercury? Was it our intention to cause climate change? Was it our intention, to pollute the oceans? I mean, there's 6 times as much plastic as plankton in the Pacific Gyre north of Hawaii right now. I mean, did we intend that to happen? So the first industrial revolution was not designed. So when we call for industrial re-evolution, what we're looking at is to look at the whole system and say, if we could design a whole system of industry, how would we power it? How would we make things? How would we act? And that way we can have a vision toward which we can move a new industrial revolution. We're not asking everyone to become an expert at everything. We're asking everyone to understand that they could use the benefit of other people's expertise so that they don't become monolithic. Whereas what we're looking for is the best and the brightest coming together in multidisciplinary teams.
Implementing these ideas, we can design products that are continually recyclable and transform our current industrial system of take, make, and waste. Done intelligently, we would see as consumption increased, so would the health of the planet.
Well, it's all really common sense. I mean, every time we talk to children, they go, well, obviously. So the children get this immediately. It's the entrenched practitioners that have difficulty imagining doing something differently. How do we love all the children of all species for all time? That's the fundamental question. And can my design do that? Is it about love of all children of all species for all time? Not just our children, not just our species, and not just now.
Living systems have been around for a few billion years and will be around for many more. In the living world, materials flow. One species' waste is another's food, energy is provided by the sun, things grow, then die, and nutrients return to the soil safely. And it works. Yet as humans, we've adopted a linear approach. We take, we make, and we dispose. A new phone comes out, so we ditch the old one. Our washing machine packs up, so we buy another. Each time we do this, we're eating into a finite supply of resources and often producing toxic waste. It simply can't work long term. So what can? If we accept that the living world's cyclical model works, can we change our way of thinking so that we too operate a circular economy? Let's start with the biological cycle. How can our waste build capital rather than reduce it? By rethinking and redesigning products and components, and the packaging they come in, we can create safe and compostable materials that help grow more stuff. As they say in the movies, no resources have been lost in the making of this material. So what about the washing machines, mobile phones, fridges? We know they don't biodegrade. Here, we're talking about another sort of rethink, a way to cycle valuable metals, polymers, and alloys so they maintain their quality and continue to be useful beyond the shelf life of individual products. What if the goods of today became the resources of tomorrow? It makes commercial sense. Instead of the throw away and replace culture we've become used to, we'd adopt a return and renew one, where products and components are designed to be disassembled and regenerated. One solution may be to rethink the way we view ownership. What if we never actually owned our technologies? We simply licensed them from the manufacturers. Now, let's put these two cycles together. Imagine if we could design products to come back to their makers, a model that builds prosperity long term. And the good news is, there are already companies out there who are beginning to adopt this way of working. But the circular economy isn't about one manufacturer changing one product. It's about all the interconnecting companies that form our infrastructure and economy coming together. It's about energy. It's about rethinking the operating system itself. We have a fantastic opportunity to open new perspectives and new horizons. instead of remaining trapped in the frustrations of the present, with creativity and innovation, we really can rethink and redesign our future.
The most common measure for the wealth and development of a country is gross domestic product, or GDP. GDP is the total value of everything we make and everything we spend. For households, this could be buying a television, a computer, food and clothes. And for companies, this means buying office materials, resources such as steel for production, energy, and services including telephones and deliveries. And for governments, they have to run hospitals and schools, provide security and a clean environment. Their job is to make sure that the basic needs of society are met. In today's world, the higher the GDP, the greater the wealth of the nation. The problem with GDP is that it doesn't include the value of important things such as the free services that nature gives us. Clean air and water, pollination of plants and crops, wild animals, or voluntary work, looking after elderly people. Another problem with GDP is that it does not include the costs to society of environmental pollution from the production of chemicals, energy and materials, or the dumping of waste and the overuse of resources. Our cities contain a lot of valuable metals. These can be collected from recycling points in supermarkets and shops. Here, the various kinds of products are separated and sold on to clean tech smelting facilities according to their price. At the smelters, each metal is handled differently depending on how it will be reused. The additional benefits are that clean tech urban mining uses less energy and creates less pollution. And on top of this, the metals will be of a higher quality and of more value than in any mine in nature.
And imagine the following. If you now have a lorry in front of you with the best gold ore left in the mountains, and you have a lorry of mobile phones, which one will you take? Well, I will take the one with the mobile phones. There's 100 times more gold in that lorry than there is in the best ore.
There is no longer any doubt that we will have to rethink the way we live on our planet. We already keep track of what we spend and buy at home, at work, in factories and in society. But what we don't do is keep track of the planet's resources that are being consumed more quickly than they can be regenerated. Instead, we need to rethink how to reduce, reuse, recycle, and eventually resource our way of living. Then it will be possible for 7 billion people, or even 9, to live on one planet.